So let's continue on with another example here of geometric sequences. And if you look at this, it says find a number of terms n in the following sequence. Well, wait a second. First thing we should do all the time is write down the formula. That's the only formula we have for geometric at this point in time. Okay, so let's look at this thing. Notice that this sequence is in fact finite. In other words, it ends. So that's your Tn value. That's got to be your T1 value. The only thing missing right now is that ratio. Think about it. Whenever we did an arithmetic, the D, the common difference, was a thing that we found first. Once we found the common difference, everything else seems to just kind of fall in line. All right, so let's find the ratio. Well, I'm going to pick a number. Minus 24. And we're going to divide by minus 12. Okay. Given it's a ratio here of 2. Oh, that's just awesome. So now we know Tn, now we know T1, now we know R. Let's throw it in this formula and see what happens. So our Tn is 192 minus 192. Our T1 over here at minus 6. Okay, our ratio here is 2. And this is to the power of n minus 1. Oh, isn't that just great? All we got to do now is we just got to solve this. Easiest thing to do right off the bat, divide this by minus 6, divide that by minus 6. Let's cancel out those minus 6's here, and let's see what we get. We have 2 to the power of n minus 1 equals to whatever minus 192 divided by minus 6 is. Well, I'm going to bring up our calculator here, and we're going to take our minus 192 and divide it by minus 6. So minus 192 divided by minus 6, and I get an answer here of just plain old 32. Now, if that's 32, and that's to the power of n minus 1, some people can predict this right away and figure it out. But let's just, for an example, say I can't figure this out. Well, what this must be then, if you think about it, this 32 has to be some form of 2 to the power of something. Right? Has to be, because of course it has to equal to 2 to the n minus 1. So this has to be to the power of something. Well, let's think about it. Well, think about it. 2 to the power 2 we know is 4. 2 to the power of 3 we know is 8. 2 to the power of 4 we know is 16. 2 to the power of 5, there's 32. Awesome. 2 to the power of 5. So here, I'm going to teach you a little bit of something that's really, really cool. Watch this. This becomes 2 to the power of 5 equals to 2 to the power of n minus 1. Now, if you remember in the rational expressions unit, things on opposite sides of the equal sign can always cancel. So watch what I'm going to do. I'm going to cancel the 2's out. Why? Because they are the same. This is going to give you 5 equals to n minus 1. And check this out, baby. Plus 1, n equals to 6. There are 6 terms in this original sequence right here. That, in fact, is T6. Awesome. Holy smokes, that works out just so beautifully. And if you're not sure, if you're still not happy about that, I can give a proof to you right now. Remember, our form was Tn, formula was Tn, T1, R to the n minus 1. Okay, I know this is 192, but I'm going to prove it. There's T1 at minus 6. Common ratio was, in fact, we figured it out here, to be 2. Okay, so 2, and I said that this is T6. I said that that was T6, so this to be 6 to the minus 1. Check this out. 2 to the 5 times minus 6. Check this out. 2 to the 5, think about it. 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. Times 2 is 4 times 2. 4 times 4 is 16. 16 times 2, right? Works out to be 32. You've got minus 6 times 32, which works out to be, check it out, minus 192. And that just confirms that we did the right math and used the right formulas.